Hello, YouTube. Normally, I stream on Twitch and edit down the videos from Twitch to post to YouTube. But unfortunately, my Twitch recording of this particular problem ended up having music in the background that I normally don't have. So I wasn't able to post it to YouTube because it would result in copyright issues. So I figured what I could just do is read the problem and then talk through my solution. Maybe that would be interesting, hopefully. If not, then feel free to skip. I won't feel bad. This problem is problem number 5 in the list. It's called Compass Calibration, difficulty rating 1 for part 1. Following the analysis of data from the drones surveying the Atlantic Ocean, your lab is confident that they've located the fabled city of Atlantis. Your team has been handpicked for this once-in-a-lifetime research mission. What an honor. Over the course of this trip, you'll know you'll be facing a host of natural and supernatural threats. Luckily, your trusty laptop is waterproof, so you should be fine, probably. Soon enough, you and your team find yourselves in a sturdy land vehicle built for all-terrain travel, which will autonomously drive to the beach. There's just one small issue. The autonomous vehicle isn't driving itself. Look, it's a navigation module. It must be faulty. Excellent. That's not hard to fix. You'll just have to recalibrate the vehicle's compass. You start the calibration diagnostics. 600 numbers and a long sequence of symbols appear on the monitor. Each number represents a meeting in milliradians. The first number in the file represents the initial compass offset. However, this isn't the actual compass offset. The following numbers represent the magnitudes of the corrections to the initial compass offset. So the second number corresponds to the first correction, the third number corresponds to the second correction, and so on. The sequence of symbols is 599 characters in length, consists of plus and minus, represent the sign of each correction. First symbol corresponds to the first correction, second symbol corresponds to the second correction, and so on. The vehicle's actual compass offset, measured in milliradians, is calculated by adding all the corrections to the initial compass offset. So what I did, do not enter milliradians as part of your answer, it says. What I did was split the data, right? And then split grab the operations from as the last line. This pops off the blank last line that this generates. And this pop grabs that last line with all the pluses and minuses. And then this just converts all of those lines from text into just I64s. And then part 1 is to iterate over all of the numbers, skipping the first one, because we put that one in the fold statement here. We zip the remaining corrections with the operations that we're going to be doing. The operation is plus, we add. The operation is negative, we subtract. And if we panic, we panic. And then that's the result, is just adding, folding all of those entries into the answer. And we did get the right answer for that. Part 2, difficulty rating 1, also. You enter the actual compass offset into the vehicle, and you notice that the navigation system is still faulty. Perhaps you missed something? Oh, the sequence of symbols is stated to be displayed in reverse order. So you missed a key instruction, no worries, it happens to the best of us. So we have to apply all of the negatives and positives in reverse order, which is easy enough. We still do the number, take the numbers, iterate over them, skipping the first one because, again, we fold it in. This time we reverse the operations. So instead of ops chars, we say ops chars rev, and then the rest of the code is the same. That just folds over all of the numbers. And we got the right answer. Difficulty rating 2 for part 3. You've taken a step in the right direction, but the navigation system still seems a little defective. Whatever caused this issue, it better not be another missed instruction. Oh, would you look at that? Another team member spots another instruction you somehow missed. This is going great, isn't it? The initial compass offset and all corrections are meant to be 2-digit numbers. The instruction states that the readings are represented by the 2 numbers on pairs of consecutive lines. This means the first reading is represented by lines 1 and 2, second is lines 3 and 4, and so on. So all we did for this one is pair them up. So I created this big nums vector, which is basically iterating over the nums, taking pairs, the consecutive pairs, and then multiplying the first digit by 10 and adding it to the second digit, and then collecting that up. And then we just do the same thing we did up here. We iterate over the numbers. We skip the first one because, again, we fold it in. We do the reverse. It doesn't say to do that, but it's implied, I guess. Reverse the operations, add everything up, and that's our answer. And then we got 8, 12, and 517 for my particular input. The epilogue is, you enter the actual compass offset into the vehicle and it starts driving. Navigation module is working properly now. As your team begins to chat, you make a mental note to yourself to read instructions very, very carefully in the future. And that's puzzle 5, and hopefully that's the only one I'm going to have to do like as a, here's what I did, as opposed to editing up my Twitch stream. But what I can do as a sort of a YouTube exclusive is to create a function which does this fold for us and the zip for us, and maybe that'll be fun to do. And I'll do that sort of live without messing around with editing or anything like that. So let's see if we can write a little function which will take the list and take an iterator of chars and then do the fold for us, right? So we can call function add up or calc corrections. And let's see, nums will just be a vec of nums here of I64. And then we have a chars iterator, right? So let's call it iter chars. Does that all have to do? We'll find out in a second. And this is going to just return an I64 as a result. So let me do that. Can we pull this in? Standard string chars. It's never used. So let's see if we can basically pull this in. Can I just put iter there? It doesn't like this for some... Oh, there we go. Okay. Does this compile? It does. So can we place that in place of here? Can we just say calc corrections, nums with ops chars rev? And will it give us the same answer? Let's find out. Bake and run. This is this problem here. So we know it's 8, 12, and 517. Let's save it. No, it blew up. Oh, we have to pass in a reference. And it doesn't like this. Expected chars found rev. Ah. Yes. That's a problem. Okay. I was hoping to be able to make it just a generic chars thing, but maybe what we can use, I was going to say, well, we can use the either crate. But for now, let's just do rev chars. I think that's all I need to do for that. Once I pull in standard iter rev. Yeah. And we still have 8, 12, and 517. So now part 3 can also do this. Calc corrections, big nums, ops chars rev. And it's still 8, 12, 5, 17. Now, the only thing I can't do is use it here because this is a chars, not a rev chars. Is there some way, is there some way I can say it's a function that iterates over with the result of char? And you might be able to do that. You might be able to say like iter item equals char, something like that. No. Yeah, that's not an issue. It says 12 other candidates. What other candidates can we put in here? Is there... I was hoping there'd be like a standard iter char, standard slice char, maybe 19. No, it doesn't like that. Expected one generic argument. Okay, well, it's saying remove it. So, oh, okay. So T here. We'll just see what happens. Now everything blows up now. Expecting an iterator. I mean, it is an iterator, but it doesn't work that way, apparently. All right, so it's working again. I'm trying to think if there's a specific way we could just say any iterator which yields a character, because that's what this does, right? If we take a look at this type, it does implement iterator item char. Let's try that, actually. I don't know why there's a backslash there. That's weird. That might be a bug in the docs. So if we say iterator item equals char like this, and to make this an I, that worked. Okay, so maybe we can do that up here now. Just calc corrections, nums, ops, chars. Yeah, look at that. 8, 12, and 5, 17. We're now no longer using these guys, so we can clean that up. And now we have parts 1, 2, and 3. The only thing I wish we could do something differently here that would keep this all on one line. Let's rename this function. Calc. Yeah, there we go. And then we can just put big nums here. Parts 1, 2, and 3. And there we go. Git status, git commit-am code cleanup for problem 5. Push that up, and it should be up here. And there we go. And that's this problem. Thank you for hanging out with me. Thank you for putting up with this sort of YouTube one-off exclusive. And I will see you in the next video. Take care.